So in this MATLAB tutorial, we're going to switch gears a little bit to a related topic, image processing. The first thing I want to talk about is what is an image? So we can compare it to sound waves since we've already studied those. Now let's think about the most raw data possible. So firstly, whereas sound is a one-dimensional function, images are two-dimensional functions. We have an x and a y and a z, and so the z is the value at that x and y. In fact, you can think of a heat map or a contour map as basically images. So we have a 2D function, okay? X and y are continuous coordinates in space. And like with sound, we have to sample the data in order to store it in a computer. So with sound, we're sampling across time, and we call that the sampling frequency. What's analogous to the sampling frequency when we're dealing with images? I'll give you some time to think about that. This is actually probably pretty familiar to you. So with images, the analogous concept would be the resolution, right? So the amount of fine-grainedness you put into each point in space. For example, Udemy videos are required to be recorded in HD resolution. So now let's suppose we have an image called A. A will have the indexes I and J referring to the XY coordinates. Just write this down if it helps you. So we have an image A, and then AIJ would be the XY coordinates. So now let's think about what would be stored at AIJ. In other words, how do we store a pixel? So now let's suppose we store just one number at AIJ. So it's a two-dimensional matrix or a table. It's a table of values at each point xy. That matrix would represent a grayscale image, right? Because if we only have one number, we can only represent intensity. So 0 would be black and 1 would be white. And so AIJ would be the intensity at the point IJ. In order to store a color, we need three parameters, R, G, and B, or red, green, and blue, and this is what we've been looking at for the entirety of this video so far. So these values usually vary from 0 to 255, so we can have a total of 256 to the power of 3 possible different colors. So let's look at what the value of that is. So that's about 16.8 million different colors we can represent if we store values from 0 to 255 for R, G, and B. Now what this also means is that if we have a 500 by 500 image, the matrix that we use to represent it isn't 500 by 500, but it's 500 by 500 by 3. Sometimes this is called an image bitmap. Alright, so now that we've talked about images in the abstract sense, let's talk about how you would actually open an image in MATLAB. So there's an image processing toolbox that we won't be using a lot of in these tutorials. MATLAB has a function called IMRead built in. We are going to use that function to read in a very famous picture often used in image processing. So if you ever take a computer vision course or a multimedia course, you've probably seen this image before. Okay, so let's look at the size of A. So it's 512 by 512 by 3, so a three-dimensional matrix as promised. Notice the data type is uint8 instead of double that I have for my other matrices, which is the default in MATLAB. So a uint8, the U stands for unsigned, int stands for integer, and 8 means it's 8-bit. Okay, so we think about how many values could be stored in a unsigned 8-bit integer. Let's go ahead and calculate that. You should pause this video and try to think about the answer yourself first. Okay, so the answer is 2 to the power of 8, and that's 256. So as we discussed previously, the values for Rg and B go from 0 to 255, which is 256 different values. There's a function called imshow that will essentially plot the matrix as an image. So that's the image, the famous Lena image that's used for image processing. So in this MATLAB tutorial, we're going to do some basic exercises to just get you working with image matrices, and they're going to be very similar to the exercises we did for sound. So the first exercise I want to do is, how do we flip an image upside down? I'm going to give you a minute to think about that, so please pause this video and then come back when you have figured it out. Okay, so if we want to flip an image, it's going to be exactly the same as we did for sound. So if you recall, a sound was stored in using different samples in different rows, and essentially that's what's happening with an image also, right? So the top of the image is the top of the matrix, and the bottom of the image is the bottom of the matrix. So if we do flip UD, which stands for flip up down, of the image that we loaded, and then we imshow this image, we see the original image flipped upside down. So now here's something we couldn't do with sound, because sound is one-dimensional, so you can only flip it one way. Now let's suppose I want to flip the image in the horizontal direction. How would I do that? So I'm going to give you a minute to think about that. Please pause this video and then come back when you figured it out. Okay, so if you remember, when we were talking about sound, we looked at two different kinds of flip. There was flip UD, which flipped vertically, and flip LR, which flipped horizontally. So all we have to do is call the other flip function. I'm going to imshow this flipped image. Right, and so this is the image flipped horizontally. And of course you could flip the image both vertically and horizontally. To get this. Okay, so now the next exercise we're going to do involves working with color. So I've said before that the third dimension in the matrix are the red, green, and blue channels of the color. So how can we show this? So let's say I only want to view the blue channel. How can I visualize that? So I'm going to give you a minute to think about this. Please pause the video and then come back once you've figured it out. Okay, so usually we say RGB because red is the first component, green is the second component, and blue is the third component. So I'm going to assign the original matrix A to a temporary variable B. I want to view blue, so what I want to do is I'm going to set red and green to 0. So how would I do that? I say colon to select all of the rows, another colon to select all of the columns, and then I put a 1 because I want to set the first channel, which is red, to 0. I'm going to do the same for the green channel, and so now only the blue channel has values that are not 0. So if I IM show B, now we see only the blue components of the image. Right, and so if I IM showed one of the other channels that was set to 0, it's just pure black. So 0 is black, means no intensity at all. So next we're going to look at the green channel. So I'm going to set G equals to A, G colon colon. So I'm setting again red to 0. But now I don't want to set green to 0, I want to set blue to 0. So it's G colon colon 3 equals 0. And I am show G. And so here's the green channel. So it's a little bit more intense, or it has a higher intensity than the blue channel. We can see visually. So now let's say we want to view the red channel. So we're going to do something very similar to the above. So I don't want to set red to 0, I want to set green to 0, which is the second channel. And I want to set blue to 0, which is the third channel. So I IM show R, and this is the red channel. So one thing to notice is that no matter which channel we look at, we can still pretty much just view the image. Now why is that? It's because every color contains a red component, a green component, and a blue component. So when you see colors, think of them as sort of a mixture of those three.